So I believe I'm now officially recording.
Great. It says so, at least.
Great. Well, we are now at 5 after the hour. I don't know, Jonathan, if you have any introductory remarks, but I just wanted to say thanks everyone for attending and Joel for giving your paper. It's a shame that we're not all meeting in person, but on the other hand, I think we have people attending who might otherwise not have been able to participate. So it's turned out well anyway. Jonathan, do you want to say anything about the Salon in general?
Well, I don't want to take up any time from anybody, just to say welcome to everyone. And the Salon was an experiment to start with, and it continues in that tradition with experimenting with the Zoom format. So please feel free to give us feedback on how this works and if you've suggestions or seen other things that work better. But I'll let the speakers speak for themselves.
So with that, Joel, it's all yours.
Thank you. Yes, so I should start by sharing my screen, shouldn't I? Okay, you all see my cursor and everything?
Yes.
Good. So, okay, so yes, I'm Joel. Thanks for coming. I'm a first-year PhD student under Thomas Petschek at Kent, and yeah, this is my talk. What does it take to create with domain-appropriate tools? So, this talk will center around two demos of a system that I've built. But before I show them, I think it's important to first sketch the motivations that led me to make the system in the first place. And after showing the system, there'll be enough context for discussing the challenges that I faced in building it. And I would like to note that this talk was originally an hour long, and I've stripped it down to half an hour. So naturally about half of, well, some details have been pushed out, but I'll be happy to elaborate on anything in the Q&A. So to start off, in software engineering, we often say, use the right tool for the job. But as opposed to what exactly? What's at the other end of this scale? Well, the opposite of tailoring your tools to the circumstances would be using the same tools regardless of the problem domain. And this can be called the one-size-fits-all approach. I think the easiest example of this is the way that we code. In order to bring anything to life, to make it dynamic, we typically have no choice but to write text. And make no mistake, this might be perfectly okay for some or even most situations. It's just that the cases where it's not appropriate are very frustrating if you're forced to use this. And the obvious failure mode that comes to my mind is anything in the visual domain. Anyone who's ever had to describe a picture with a sequence of drawing commands or XML markup will respond to this point. The most domain appropriate way to describe a picture is usually to just draw it. And you can draw static pictures and animations on a computer, but when you want behavior to be dynamic and computable, you're still stuck with code. So we shouldn't expect any medium, including text or anything else, to be equally suited to all possible tasks. So one way to perhaps go beyond the one-size-fits-all approach to coding is to make developing more like using. There's already a huge diversity of ways of using software, and you think this ought to give rise to a similar diversity of styles of developing software. And this is certainly the idea behind end-user programming. If just being familiar with the de facto standard graphical user interface, the GUI, if that could suffice for programming anything you could think of, then this would free the vast majority of users from their current passive role as mere consumers of software. But isn't this perhaps too broad a scope to look at? I mean, spreadsheets and Paint applications are both use graphical user interfaces, but they're still very different domains of use. Can we conclude that Excel should be programmable by some sort of spreadsheet? It might work for simple tasks like adding a menu item. If Excel could display the menus as spreadsheet columns or something, then maybe it's as simple as filling in a new cell. But still the idea is a bit hard to grasp and dubious, and the devil's in the details. And it certainly doesn't generalize particularly well to the case of Paint applications. Is the program behavior somehow now represented as colored pixels? There is actually a programming language called Piet, which works in exactly this way. But as you can probably tell, it's an esoteric language meant for your amusement and challenge. So if bringing development closer to use gives you an even more confusing representation than text, then there might not be any point in doing it. On the other hand, it is worth mentioning that there are domains that already do work this way. We have to notice this. Text editors, for example, themselves are software, and programming happens via text editors. So the development of these tools does seem to rely heavily on text editing skills, not to mention general literacy, for example. And this is even more pronounced with scriptable editors like Vim or Emacs, this idea that you can develop in a similar manner to use. There's also the fact that creating software is one of the uses of your operating system and all of its applications taken together. In short, evolving how your computer works is indeed done by means of your computer. And finally, while we've seen this approach is a bit odd for things that aren't designed specifically for programming, like Excel, it does work for actual programming languages. And this brings me to the specific event that first got me thinking about development as use. It was a paper that I read called Open Reusable Object Models. And it sets out the design of an object-oriented programming environment called ID, which is built around two main properties. The first is that it's meta-circular or self-describing. You're supposed to be able to change anything about the system using itself. So in addition to all the uses of object-oriented languages in general, you can also evolve the underlying platform without having to know the original implementation language like C++. So it's quite clearly embodies this property of evolving. Is just supposed to be another use of it. The second property is that it's small. It's in some sense the minimal necessary structure to be able to kick off a self-improvable software system. And I think the problem with Smalltalk and similar systems to that is that they tend to be very big and complex. And what it's trying to do is just distill the essence of the first point of meta-circularity. So in order to better understand the paper, I wanted to try and explore a running version. And at the end of the paper, there are a few pages of C code for a reference implementation. But this is a purely in-memory version of the system. Not even a command line interface is there. So I would want to, the only way to be able to explore the thing would be in a debugger. Rather than adding command line code myself, I thought that this would be a good opportunity to just do much better than that. From my perspective, I'd just been through a paper chock full of diagrams like this, and even drawn my own diagrams in order to understand the paper. And I took this as a sign that my mind found the diagram representation that they'd chosen particularly appropriate. And so I resolved to implement it in a way that was as close as possible to drawing the diagrams on paper, and hence to use it in the same form. What I wanted was runnable diagrams. And so that is what I'll show you now. So here is my implementation of the ID system from the paper as runnable diagrams. And it's built on a more primitive substrate of nested boxes. Each of these boxes has a name in the top left corner, and the whole thing works as a hierarchical tree. So hopefully I can use this as a way to quickly show you what the ID system is all about. So it's an object-oriented system, and its central concept is the object. Some of these boxes, these top-level boxes, count as objects, some don't. Some are just plain boxes in my separate box substrate that I built the ID system on top of. So if I create a box here, call it my obj, then at the moment this is just an empty box, it's not an object. To get it to qualify as an object, I have to first say what its class is, except in ID, this is called a vtable. They choose to call it a vtable instead of a class, but it's functionally the same thing. So I create a vtable field and point it to, I'll just point it to this object here. This is the object vtable, which acts a bit like the object class in Java. It's just supposed to be the general default root class that everything delegates to in the end. So in the most banal possible way, I'm just saying this is an object now. And because it's an object, I can now invoke methods on it, or send messages, in other words. And the methods that are available to invoke on it can be seen here in its vtable, and there's only one, say hello, and there's JavaScript code implementing it here. So I'm going to write code to actually send a message and show you what happens. I can do that by creating a new box and just pressing enter to get a text box. So first I just have to get a JavaScript reference to the thing. I'm going to call something that finds the box called myObj and gets a JavaScript reference to it. And once I've got that, I can type send to the obj and say hello. So send object say hello. If I press Control Enter to run the code, then we see down here in the JavaScript console, we see a little message has been printed out. It'd actually probably be better if I made it pop up instead, and I can do that by changing the code here and rerunning. So this is better, you can actually see it better here. So this proves that it ran that code in the context of this object we made, because it's actually mentioned its name, hello world from myObj. So to dig into exactly what steps it took to send that message, the first step when you send a message to an object is to first consult its vtable. So you follow the vtable pointer, and we end up here at the object vtable. The next step is to associate the string say hello to the method implementation, to the code to run. That's called lookup or dispatch or binding or something. So we want to look up the say hello method. And this could be hard coded in, but in the id system, this is actually accomplished by another message send. Because if you notice, this object vtable actually has a vtable pointer of its own. It's an object, just like all the others. Classes are objects in this system. And so when we send the lookup method, the lookup message, we say lookup say hello, and we send that to the object vtable. So again, it's another message send, so we follow its vtable pointer, we end up here, and the lookup method lives here. And this is the vtable, which is sort of the class describing how classes behave, including itself. As you can see, the vtable points to itself as its own vtable. So it's the class that describes how classes behave, including itself. And what this lets you do is it's entirely possible in id to have multiple vtables, which all might implement the class concept slightly differently, such as by looking up methods differently or having different internal structure. In the default state, there's only one vtable, but it supports different types of classes, basically. Anyway, at this point, we've got to short circuit the lookup process, because if we keep sending messages, then it's going to do an infinite recursion. So we short circuit it here and kind of find lookup in a hard-coded way. And so we were looking for the lookup method, we find the code, then it applies the lookup method to the object vtable. And what that does is it finds say hello and obtains this code. And then that returns this code and applies this code in the context of myObj. And then that's the end of the process. And those steps of sending a message are explicit and editable down here in these two functions, send and bind. So the OROM send that I called here, the code it's actually calling is in this box here. And those steps, you can change them and modify them and view them in the system. And that's basically the id system in a nutshell. I have omitted to explain this box down the side here. What this is it's the system starts in a more primitive state, and this code just initializes the system. It bootstraps it into existence. There are some slightly interesting things I can say about it, but I can't go into it now. I'll explain it later if you want. So in summary, what's happened so far is I came across an interesting paper and I wish to explore the system in it. The paper had already picked a representation that seemed more appropriate than anything else, so I plugged the obvious gap and made runnable diagrams to model the system. And this visual substrate of nested boxes that id sits on top of, it can be used independently of it as well at a higher level. So it's this system is the id system, but it's built inside this more general box substrate. And if this demo of a general object-oriented platform may have felt a bit obscure or technical, then I have here another example of bringing programming closer to use in the same skin, but without id. So I've got here some word boxes that you can move around individually. And these word boxes have been laid out, placed in their positions by this text layer algorithm in this code. Like you expect, this algorithm has certain parameters, such as the amount of space between words, or the amount of space between lines, or where the first word on each line is placed. And these somewhat arbitrary constants are inherently visual. The way that you figure out what value they should take is by tweaking them and seeing if it looks right. So it's a bit useless to have them as precise numbers in the code. And it seems like they seem like good candidates for lifting out of the code and into something more visible and tangible. So what this code actually does is it gets those values for spacing from these control boxes here. So if I increase the spacing between these two, what you could call abstract words, and then rerun the algorithm, then it reflects the new interword spacing. And similarly for interline spacing. And well, I can also modify where each line starts. Because I've moved this, I've also modified the spacing as well. So some obvious extensions to this scheme would be things like being able to infer the text direction, like right to left, from the arrangement of the control boxes here. So if I did this, what I'd want it to do is arrange right to left. Currently it doesn't support that, it breaks. But you could have right to left and vertical text. That seems like a natural extension of this. Yeah, I'm just trying to use this as an example to show what automation closer to use could look like by choosing a problem domain that this box representation to naturally lend itself to. Whenever I think about laying out text, I always think about it in terms of boxes. So it just seemed natural to use this. And it is an id, it's a bit more concrete. But yeah, this nested box substrate came about as a domain appropriate tool for implementing the id system, even if it's applicable to other things as well. And this is all well and good, but it didn't come for free. So I'll now turn to the question of what it took for me to obtain this domain appropriate tool. What was the cost? And it certainly felt like there was too much work involved to achieve something as conceptually simple as movable nested boxes. I kept finding myself filling in functionality that wasn't particularly unique to my use case, otherwise known as boilerplate. There was a huge gap between the technology that I could start with, JavaScript and web APIs like SVG, scalable vector graphics. There's a huge gap between that and my end result that I wanted. The term polyfilling seems appropriate for this. The classic example of polyfilling that I know is from back in the past when JavaScript arrays didn't support a map operation. But what JavaScript lets you do is it lets you just augment the array class with your own implementation. So JavaScript supports polyfilling. This is a good thing. It's just that polyfilling itself is still work that the user has to do. They have to fill in something that should have already been there. And a lot of the things that I had to polyfill in for implementing my id system, they can be collected under the umbrella of what I call user interface physics. So this includes things like being able to treat shapes as rigid bodies, except you don't need to account for rotation. So I call this translational rigidity because you can move them around. And you can find this sort of behavior in any desktop windowing system, which lets you treat your rectangular regions of the screen as movable bodies, but probably doesn't let you rotate them, at least not at arbitrary angles. So obviously I wanted this translational rigidity property for my boxes. Another thing I wanted was to be able to resize boxes, which is another parallel with Windows systems. And as a final example of UI physics, there's the common sense notion that solid objects don't intersect each other. If they didn't, then we'd, solid objects don't intersect each other. And in the text layout demo, any acceptable layout of words, any acceptable layout has to obey this property of solid objects don't intersect. If they all intersected and didn't obey the property, we'd reject it as a failure and fix the algorithm. So this physics knowledge has actually been implicitly embedded in the design of the algorithm, but you could just as well imagine this fact being made more explicit as a visible rule perhaps or something. And there's one key piece of functionality that makes these three behaviors possible. So if I go back to the demo, you can see these arrows that you can draw between boxes. And a key thing is that these arrows need to stay pointing between the boxes if the boxes move. And this relies on being able to listen for changes in the global position of boxes. And you'd expect this to be provided by HTML or SVG, but bizarrely, at least at the time I worked all this out and implemented it, HTML and SVG don't seem to provide the service of listening for global position changes. And I also see this partly as a shortcoming of the JavaScript language. So JavaScript is an imperative language, but it only supports what I could call dumb state. So you can set anything to any value, and that's it. But in any software system, especially graphical interactive software, there are certain rules of internal consistency. If I move a corner handle of one of my boxes, then the default dumb state behavior is where it just separates from the box. This is not what I want. What I want instead is for the handle and the corner of the box to be coupled. I want some invariant to be maintained over time. In this case, the invariant is these two things always occupy the same position. So to polyfill in this missing functionality, I basically had to create my own network of pieces of live state, which were able to notify others when they change, and then hook these up to the relevant SVG attributes in the end. And you may recognize this as the observer pattern, and it's related to reactive programming. But I previously thought of these as niche patterns or paradigms that you only get out in special circumstances. Whereas nowadays I find all of this infrastructure unavoidable. And I suppose I'm surprised that live state or the observer pattern isn't built into the JavaScript language itself, given how it's so necessary for so much commonplace behavior, especially in user interfaces and the sort of things you'd expect in web apps. It reminds me of the design patterns and how what's a pattern in one language can just be a language feature in another. So in old versions of Java, you had to write an implementation of first-class functions yourself as what's called a strategy pattern. Whereas in something like modern JavaScript, this is just a language construct with very light syntax. And I kind of feel the same sort of things going on with the observer pattern and functional reactive programming. So I've been talking about maintaining invariance over time. And one example of this that I want to show you is the translational rigidity that I mentioned. So if I move this box here, then I expect all its child boxes to move with it. And luckily for me, SVG does provide this functionality for free, at least between parents and children in the hierarchical document tree structure. However, this tree structure is the only context where it provides this translational rigidity. But I've got a requirement that doesn't fit with the tree structure, which is with these arrows. For these arrows, I need both endpoints to move with the box that the endpoints are attached to. And the problem is these arrows can't be children of these boxes because then they wouldn't display over everything. In order to get these arrows to display over the top of everything, they need to be outside this hierarchy. They need to be siblings of the top level boxes. So they can't be children, and I can't take advantage of that free SVG feature. So I polyfilled this in, and I can show you how I did it if I reveal something that's currently hidden. I'm going to set something to visible. Yeah, so this scaffolding has just revealed itself. I thought the simplest way to express that 2 points are always a fixed displacement from each other would be to have a rigid rod between them. So that's the red rod here. So when you move, when you change the position of one of the endpoints, this change in position is transmitted just to the other endpoint, and that preserves the relation that I want to preserve. If I click on this box, you can see that it has control of the other endpoints. So I also had a modified version of these red, fully rigid rods that is in the border of this of boxes. They're the yellow half-rigid rods, and they let you resize things. And I call that they're similar because they transmit changes in one direction, but not in the other direction, and that's what makes them horizontal and vertical. And I also tried having these 4 border rods be red and fully rigid. I was hoping to get a behavior where, in order to move a box, instead of what you have to do here, which is move one endpoint, one corner, and then move the other corner, if these 4 rods were red, then you'd just be able to drag a box around from any corner. Unfortunately, this led me to the most frustrating technical challenge of the entire system. So I'll explain it briefly.
So just a time check, Joel, we've got about 5 minutes left.
Okay, I think I'll have to zoom through this then. I think I'll have to skip this. Basically, I ended up biting off more than I could chew, and I need to do more research into how to send messages around graphs in a way that makes sense. Yeah, it was supposed to go round the graph only once, but it actually went round twice and applied the changes, applied duplicate changes, which distorts the box. So I didn't have time to go into that, but I know there could be some solutions to it. So those are my observations about polyfilling user interface physics. The other broad theme that I want to discuss is how APIs and libraries commit you to a single way of representing things. So take this rectangle. How can we describe it? We could say that it's a top left corner, a width, and a height, or any of the 4 corners, a width and a height for that matter. We could also say where the center is and provide a half width and a half height. We could even ditch width and height altogether and say that the rectangle extends from this corner to this corner. We could even just give all 4 corners of the rectangle, even though this is redundant, because once you know 2 opposite corners, you can infer the others. And it was actually this representation of all 4 corners that was ideal for my use case, because I really do need 4 movable point handles to let the user resize the box from any corner. But the important point is there are just a lot of different ways to describe the same thing. A simple rectangle has many ontologies associated with it. But my chosen platform, SVG, doesn't recognize or support this fact. Instead, the SVG specification essentially defines a rectangle as an X, Y width height. It says that's just what a rectangle is. What they did is they picked one of those many ontologies and committed all users to it. This is the one-size-fits-all approach rearing its ugly head again. And faced with this fact, there's pressure to just work in this representation, doing constant mental work to translate whatever representation you're thinking in into X, Y width height. But in my case, I was determined to use the ontology that made most sense to me. And the polyfill that I did for it was exactly this, this decoration that can be attached to any box that lets you resize it, this rectangle controls decoration. And you can use it as a human to resize boxes. I also use it programmatically to whenever I want to lay out boxes with some spatial relationship. So I use it in this code as well. There's also the other significant example of a forced ontology in web development, which is the event listener model. So many events like mouse button events, keyboard events, and the like, these represent changes to the state of some physical device. But the keyboard keys and mouse buttons are really the same type of thing. They're both buttons. They both have this binary state, pressed, not pressed state. They just live on different devices, the mouse and the keyboard. And what this means is they really ought to be interchangeable. It shouldn't take too much work to substitute a keyboard key for a mouse button or vice versa. And this is exactly what happens all the time in PC games, where there's typically a screen to let you do remapping of keys or buttons to commands in the game. But the official ontology of the web makes it non-trivial to do this. Instead of modeling the situation as the explicit changing of some piece of live state called left mouse button, we just get two separate functions called on mouse down and on mouse up. And the situation is similar for the keyboard keys, but this is just one of many possible ways to slice up the 3D space of possibilities. Now, this example of keyboard-mouse interchangeability isn't quite something that I needed in my system. It's just an example. But one thing that I did want was for things to follow the mouse when you drag them. And my polyfill for this was a piece of live state called left mouse button is down, along with another piece of live state called pointer position. And so in this scheme, to get something to follow the mouse pointer until further notice, all you got to do is say subscribe object position to pointer position. And as a result of doing things this way, one region of the code essentially ended up being a bunch of device drivers, which translate the web's ontology into mine as early as possible. And this whole business of APIs fixing the way that you express things is pretty normal. I just think it's a suboptimal norm. And the ability to support multiple ontologies at the same time is a definite research area in programming languages. But it's worth admitting here that all I managed to do was to force my own ontology to replace the existing one. This is far from a world where multiple ontologies can just coexist instead of compete with each other. I'd solve my immediate problem, but if another person wanted to work on this, then they just find themselves stuck in the same position, stuck with my ontology, and they might have to polyfill their own in. What stood out to me about the rectangle example is how the SVG specification is all in English, so it becomes a human's burden to interpret the X, Y, width, height fields. But if the computer had enough information about how the different parts of a rectangle relate to each other, then it would be able to figure out the X, Y, width, height that it wants from whatever information you give it. And further down in the specification, I found this bit, which is literally spelling out how you draw a rectangle using the more general path concept of lines. It's essentially telling you what the X, Y, width, height mean in English, though, how they relate to what you end up drawing. And it's even got all four corners of the rectangle expressed in X, Y, width, height terms. This is so close to being machine readable. And I think it'd be nice if this code could be run in the API on the computer instead of in the developer's head. Okay, so I've run you through my motivations and what I did and how I did it. So I will finish off with a sketch of where I want to take this project. In the abstract of the id paper, there's this pithy summary of the main point. Id is supposed to allow the user to uproot and surpass any design decisions made by its author. Whereas in conventional practice, in a conventional platform, if there's some unwise or otherwise disliked design decision, all the designer effectively do is say, I'm sorry, and either change it for all users or not, and the users just have to wait for something to happen. And this is even more the case for end user software. And the analogous vision would be to relax this exalted position of author or designer to merely be original author or author of the initial version of the system, and to have users of the software just be further authors themselves. And I really think this relies on getting rid of this total separation between development and use. In my particular research direction, this looks a lot like me escaping my text editor, because currently if I add a new feature or come up with new notation in my system, then I can make use of it in the system. But if I'm back in my text editor editing the code that isn't exposed in the system, then I'm not able to take advantage of any innovations in the system. Whereas what I'd like to do is just be able to expose most of that code in the system itself, in the boxes, and leave behind only a tiny minimal kernel of code in the files that's not accessible from within the system. Because at that point, any innovation in the system can be turned back on itself and play a part in further improvement. And at that point, this piece of software could finally be worked on solely by means of itself, or developed in the same way that it's used. Okay, that is the end of my talk. Thank you for your time, and I will defer to the response now.
Joel, thank you very much. Antranig, do you want to go ahead with the response? And yeah, applause for Joel. Antranig, I believe you're co-host, so you can go ahead and share your screen.
That's great. Thanks very much. Can I just confirm that I'm audible?
You are audible, yes.
That's great.
Audible.
Next, I find the screen share button. Oh dear. Phew.
Wonderful.
There it is.
You can see it.
Great. Sorry about this. There we go. Okay, and does this appear appropriate? Hopefully there isn't
Yep.
some
Yeah, it looks good.
horrific
Good.
recursion of people's video being shown to them. So, yes, firstly, I'd like to thank Joel for a great, well-presented talk and well-motivated along issues which are dear to many of us. I think all of us, well, many of us that I know of wholeheartedly approve of the core goal of breaking down the barrier between design and use, which is actually one of the most pernicious problems of our industry and our field. And so I just want to, so I'll be reiterating and amplifying a few of Joel's remarks where I've simply lifted slides from his presentation wholesale and plus modding several of them as we go. And I'll also be presenting various directions of how we imagine this work could be extended and hopefully to occupy a more harmonious position in communities. And so the great question is, whose domain, what tools? And I think this slogan will also be the title of Clemens's supplementary critique, because a lot hinges on this. This idea of use the right tool for the job, which uses, interestingly, I could call what I call singularizing language. It implies that this is a kind of point action where a tool is applied to a job, which is actually unrealistic model of how human activity typically takes place. And so we've got the slide which eloquently rejects the extremes. We obviously have concluded that a one-size-fits-all approach is bankrupt, but this doesn't necessarily get us much towards the solution of a problem where, in practice, there is not the job. There is, in fact, a community who is constantly at work on overlapping and variantly conceived ends. And so something that appears to be an isolated job will, in practice, have to be worked upon by authors with different skills, perspectives, and ontologies. And I'll immediately leap to the punchline in which I conclude this implies any system based on a notion of objects as classically conceived is going to fail. So I'm going to say, what's wrong with objects? Well, they're based on this false Cartesian notion that the world is exhaustively divided up into non-overlapping things we call objects. Sometimes they're called entities, which have properties which can be explained by appeal to a reductive notion of what lies interior to the object. Now we notice that Joel already ran into various incarnations of this problem in his work, and they're more fully worked out in the written form of his paper, which I enthusiastically refer you to. So even the notion of rigidity, I mean, it's a sort of interestingly Newtonian notion, but anyone who's sort of scratched beneath the sort of surface of physics knows that even the idea of rigidity is highly observer dependent. Different observers may conclude that one and the same system either does or does not enjoy rigidity for their purposes, and also that notion of rigidity is not in fact inherently explainable by an appeal to what's interior to the system. So halfway to heaven we have the notion of semiotics. So Joel has appealed to the idea of ontologies and how it would be better if we could all adopt different ontologies. And even this sort of, you could say, ontologically low level of sophistication only has one system that I'm aware of that tries to honor it. I refer people to Ollie Sharp's excellent Semprola system, about which we've had talks in the past. But in practice, what we want looks a bit more like this. From my point of view, I'm in favor of elements of a design which serve the function of what could be called lenses, and I'm aware that this term is already in use in some CS communities, so I'm really using the term fairly loosely, but I'm talking about this situation in which we have what could be called a relatively undifferentiated blob of state, which may be incarnated in various forms, and through the application of different lenses, the state may come to be seen in different ways. I mean, so for a start, we could imagine ontological chasms like the rectangle problem being papered over in this way, but in practice where far more profound chasms exist in the so-called real-world observers can disagree fundamentally on whether there are even objects in the scene at all, their multiplicity, their position, where their boundaries are. And so in practice, an appeal to explaining behavior by means of inherent constructs such as v-tables or things which are Cartesianly situated with respect to the exterior of the system are problematic. And so here is just a quick nod to things which might seem to help, but in practice haven't helped much so far. Lens formalisms, context-oriented and subjective programming languages, which in practice force people to agree on even what the basic questions are, and pretty much force you to cast those questions in the form of function calls, which, as we know, are the first evil of computer science. So we appeal to a glorious future of open authorship of designs expressed through kinds of aligned state, a remediation of the functionality of operating systems, compilers, linkers, etc., in terms of a shared substrate which has highly limited expressivity but is accompanied by rich metadata. And this metadata describes not only current but potential actions, including the capacity for entanglement. So I'll now hand over to Clemens, who will deliver a second lump of critique.
Thanks, Antranig.
Thank you, Antranig.
You have to let go of this.
I must relinquish.
Yeah.
I must yield. How do I yield? I find the right.
Press the stop button at the top in red, I think.
Yeah. Oh, excellent. Thanks. That's it.
All right. Let's see if I can share my screen, and then you should see some slides now.
Yep, looks good.
Right. I also thank you very much for the talk, and I'm very, very sympathetic to what the kind of work that experiments with, alternatives to always working on dead text when we program our computers. Also towards work on making our software more malleable and more understandable. And also I really enjoyed hearing about some of your low-level struggles and reading about some of your low-level struggles with the web as a substrate, because I've been there too and shared the pain. But for the vast majority of computer users, creating software is not really their domain. For some, it may become that even if they don't really want to, and I'm going to talk a bit about that. And I'll just give a warning. This critique is a bit more like one of those questions that's not really a question, but just someone taking the opportunity to talk about their own work for a bit. And actually, most of the work and a couple of slides, well, the work is from not even my own, it's from some of my students, Midas Nouns, Marcel Borowski, and Bjarke Fogh, who you will see here. I also stole a couple of Midas' slides. And also, disclaimer is that the questions I come with in the end, they are actually quite unfair. But let me just talk a bit about someone who struggled with their domain not being the domain of programming and programming languages. So we've been working with a group of world-leading nanoscientists for the past 2 years, and they've invented a method for doing what's popularly called RNA origami. So they fold RNA to small mechanical contraptions with the goal, for example, of making small robots that can release drugs in the body on command. And I imagine something like in E&M Banks' books, if you've ever read that. So basically, they're using the programming language of the person up there. And no, Philip, it's not Lisp. And our goal with this project was to figure out what a computational medium would look like for a group of these people who are not trained as programmers, but need to do some programming, are forced to do it, and I'll come back to why that is. And one of the things that we try to show with this project is that the story that once you learn how to code, you're good, as if the medium you edit and execute your code in is not a factor. Anyways, this is the stuff they deal with. So their domain it's RNA helices, it's RNA polymerase bindings, and it's kissing loops and all that sort of stuff. That's the sort of stuff that they work in. And it's actually physical stuff, although you need an electron microscope to see it, but it's there, and that's where they work. These biomolecular nanoscientists, they rely heavily on computational tools to do their work. They do simulations, they build their RNA structures using computation, and then at some point they get some strings that they can order and then develop it in the lab. But their relationship to computational tools is super strained, not strange, but strained. It is actually also strange. So they work on the cutting edge of science. So there weren't really any tools for them to do what they wanted to do. So they had to couple them together or build most of them by themselves. And we identified that there were kind of three characteristics that characterized their relationship to their computer tools. They had a culture that stemmed from molecular biology, where, in their own words, the machines they use, they are black boxes, and they have very little training compared to, for instance, in physics, where you often have programming classes. They are more or less absent from the curriculum in molecular biology. And actually, their biggest struggle with their computation was in their computational environment, and not as such their lack of programming skills. That was also a problem. They struggled with installing, maintaining, and debugging all of these environments, terminal navigation across different operating systems, maintaining packages and dependencies and all sorts of stuff. That was really a big pain for them, as most of them actually didn't do programming, but they used a lot of scripts and stuff in different programming language made by other people. And that really left them in a state of, we call it computational disempowerment. They have to debug code or library dependencies very, very far from the domain of molecular biology. It's simply not where their thinking goes. And then when an exception happens, then it's in a big couple of code they use, and they don't know whether it has something to do with what they're doing is physically impossible, so it's a biological or physical problem that causes the exception, or it's a bug in this code that has been written by non-programmers. So what we did was we built a prototype that aggregated some of the many scripts and tools they use in some sort of computational notebook, but where the code wasn't really front and center, but still accessible in there. And the prototype was just addressed a small part of the work they did, sort of to have a conversation piece with them. And I won't go into details about it, but a couple of things to note: they actually do their designs text-based. So what you see over here is actually ASCII art. It's a very simple molecular structure, but they build complex molecular structures out of ASCII arts, which is completely bonkers. But they like to do that because text has nice cut and paste affordances. But turning that model into a 3D model or RNA strings that they then can order is thousands and thousands of lines of Perl that only a few of them have any understanding of. So in our small notebook system, you could also access this code, but for many of them, it's just gibberish, because you can see there's just, there's literally thousands and thousands of lines of Perl code here. So what we did was that we experimented with making everything around programming for them a little more convenient, and then sort of hiding away the complexity of the actual code so they could be helped with some of the struggles of maintaining computational environments, but also to make it possible to actually do some programming from within. But obviously not many of them did that. But now I'll get to the exceptionally unfair questions. So what's the path from OROM to more domain-appropriate tools for instance, biomolecular nanosciences? What abstractions would this require? And then a side question is, how do abstractions actually look like in OROM? There. That's it.
Thank you, Clemens. So I think we've got time for questions, and I hope people are willing to stay a little late and bring questions to Joel or to our respondents. Two ways to ask a question: you can put up a little icon in the participants list, or you can type into the chat, and then we'll give you the microphone if you want it, or you can ask your question there. So would anyone like to start with any questions for Joel?
Oh, Philip raised his hand. I see.
Go ahead, Philip.
Okay, so I have a question that I haven't quite worked out the wording for yet, but something that interests me is the sort of temporal or historical position from which you asked questions in your presentation and in your paper. In that you are making this argument that, you know, why don't we have good primitives for describing for describing these graphical physics that are common to so many UIs? Why isn't this in the standard library? Why isn't it factored into language? And I noted that during the talk, there were a few comments about systems like Self that did actually provide sort of pretty substantially low-level support for these things as a reusable package. And it just made me think that, you know, the work of programming is in some ways deconstruction of these intermediate abstractions that we build towers out of. And so there'll always be, well, there's always so far in the history of programming, this is the work. It's going on continuously, and that just makes me wonder if that should complicate the questions you ask a bit. Should it more be about what is actually a high value abstraction to aim for, making commonly available? What prevents people from? What is it that causes everyone to rewrite this stuff that you've written again and again and again? Like I think the example of arrows that have to follow the things they're attached to. I imagine a substantial percentage of the people in the Zoom room have written code for that. But that is also programming. So I'm wondering how we figure out what goes in a standard library or the standard library, and is this a problem that we can address once and for all? Does that make any sense?
Yeah, I think the part of your question that I understand the most is what you're getting at about what should be in a standard library, or what should be built in versus what should be left for the community to implement. Was that a central thrust of your question?
Well, no. I guess I'm saying there's always a moving wave of things that are in or not in whatever a given community considers to be their standard tools.
Yeah.
So beyond writing that behavior, what goes into making something shareable and accessible and reusable? And are those not questions that need to be addressed in this work?
Mm-hmm. So beyond just implementing something, what things make it shareable and reusable? Maybe
more straightforwardly, I could ask: do you think that through the pain that you've had in implementing the OROM SVG system, do you think that feasibly a bunch of other people could reuse the basic physics and behavior that you've implemented?
Well, throughout implementing this thing, I've been working off the assumption that I'm the sole author of this, basically, because it's quite it's very idiosyncratic to my interests, and yeah, I've been the sole person working on it. So I certainly don't think anyone could readily reuse the implementation of the concepts that I've got. I mean, it's sort of been an experiment for myself to see, you know, this is kind of common functionality. What actually is the essential complexity of this, and how is this tainted by the incidental complexity of the languages that I'm using? And, you know, try and reflectively trying to not just blaze through it, but be a bit cautious and slow about implementing it, and see why does this feel so tedious? So I don't think people could reuse what I've got. Part of what I hope to do with just articulating the concept of something like user interface physics is to introduce new concepts and terminology to something. I mean, the user interface physics specifically is quite special here, because it's my best name for something that I just think like exists in a lot of places, but I've never seen recognized as a actual thing. It's basically when you can find an awful lot of information about designing user interfaces and about the psychology of user interfaces, but it strikes me as odd that there's no kind of theory of implementation of user interfaces, and all the same problems that you run into every single time you try and make something like that. Because every time I've worked with people on graphical user interfaces or done it myself, some of the things that I've discussed always are just kind of glossed over. They're never like recognized as, hey, this is a thing that's always tedious. Maybe what if like we kind of analyzed the problem and came up with some theory and tried to improve the situation. The best way I can describe it is a bit like if the natural philosophers of the Renaissance were developing physics and kind of just stopped at the stage of what we noticed that, oh, it looks like things fall faster the longer they've been in the air, and they just kind of stop there and don't name a concept of acceleration. They don't do any of that. They don't go on to develop calculus or anything. And so kind of the predictive and theoretical power of something like classical mechanics is lost, and instead what you have is just a ad hoc set of vague best practice and kind of intuitive knowledge. But it's just strikes me as a strange gap that I can't find any literature on, and it appears in small strands throughout things like functional reactive programming literature and things. They show kind of concrete instances of these problems, but there's nothing that just seems to collect it all together into what looks to me like a subset of physics that can reasonably be called physics, and that resembles a subset of physics in the real world, but it's just a very simplified, reduced case of it that you wouldn't necessarily want to have box 2D as a dependency of every single application. So it's like it's useful to study special instances of problems sometimes, even if a completely general solution is available, because then you can optimize for special things you know about the domain. I went off a bit on UI physics there, but I have to admit, like in this, I didn't have a concern about sharing my work, because my whole reason for embarking on this was I thought there was something really interesting about this id system, but I wanted to be able to actually try it, and then I kind of realized, well, hang on, I can't play with it in a form that actually facilitates my understanding it, so I'll solve that problem first, and now I'm there. And so any concern about sharing, I think, would be branching from getting further along the plans that the authors of id had, which is that it eventually gets combined with something else to form a platform that other applications can be built on top of. A kind of a community or shareability analysis would be appropriate there, and it could probably be severely critiqued on those grounds, I think.
There's a question in the chat that dovetails nicely here. So Chris asked if you could clarify the relationship between id and OROM. Where did id stop?
Yeah, that's a very good question.
Start?
Yes, I'm sorry I may have confused anyone about that. So OROM is my abbreviation for the name of the paper, Open Reusable Object Models. id is the system described in that paper. I used to refer to all this work as OROM because I felt that because I was publishing it on my blog and things, and I felt that was much more Googleable than id, and also it kind of it slightly differentiates it from. It's like I'm not necessarily implementing id; I'm implementing my own kind of fork of id with slight differences. So I wouldn't necessarily want to confuse it with the original thing, but there's not so much of a difference. The id system in the paper is very much like the system I showed, except if you want to think about it, you see it as diagrams on paper, and those diagrams represent regions of memory, blocks of memory with pointers to each other. And so it's basically the system described in the paper as an in-memory system, whereas mine is that, but with a user interface. Yeah, I hope that clears it up So I don't really have a deliberate scheme for using those terms. I kind of use them a bit sloppily.
That's great. Thanks. Are there other questions people would like to ask?
Lots of discussion.
Yeah, lots in the chat, which is great. Oh, I see a hand up, Kartik. Do you want to go ahead?
This is a fun paper. It occurs to me that all this wringing of hands about reuse and polyfills and why doesn't this already exist? We sort of go round and round in circles for several decades with these questions. Isn't the problem that you're requiring designers to have perfect foresight about what their users might need? Since the purpose is, in the end, is end user programming where the user is empowered, maybe the fact that you had to go through some tedium is a good thing, because now you're experiencing what the original author was experiencing. And isn't that the goal?
I don't think so. Going through the same tedium as the original author. I mean, it could serve some purposes. Like, I mean, it certainly it teaches you about going through the tedium. Teaches you that there is tedium and teaches you more about it. And so, if you personally feel, as I certainly do, that I want to avoid such tedium, then it can teach you more about how, maybe why it's there and how to get rid of it. But I think it's only useful insofar as it serves as in getting rid of the tedium. I mean, if you want a simple, conceptually simple thing, and there's a lot of tedium in getting there, then that's something wrong to me. Specifically for what my experience here, the thing that struck me as strange was that there seemed to be it's like for a platform like JavaScript or the web platform, including technologies like JavaScript and SVG and things, you'd expect there to be a gap between you've always got to pick some starting point, some tools to start from. And then you go from there to the place you want to be, the thing you want to make. But I was going to say, it got away from me. These platforms they have a certain, every language has a core and kind of peripherals, standard libraries that you can pick and choose, and basically the cost of maintaining those and coming up with those is placed on the wider community. So for each ecosystem, there's a set of problems that de facto have been decided as the responsibility of the common. It's a common concern that we all share, or it's something that's so specialized that we're not going to bother putting it into the core, but if you want to work on it, then you can do that. So every system draws that line, and I just found it weird that so many of the things that I were doing were very common things that you'd expect a lot of web applications need, especially because you could say a lot of just general native applications need, but many native applications are, say, terminal programs, whereas on the web, the coincidence between web apps and graphical user interface apps with all the attendant requirements, like observer pattern and everything, is much closer. I keep almost getting to the thing I want to say, but I keep forgetting it. Yes. So I've had the thought that in an ideal world, what you'd want to do is you'd want to be able to express the work you had to do to realize your vision in software would simply be proportional to the kind of idiosyncrasies that you have, in the way that your end product differs from the common case, or differs from a common case. So you'd be describing your vision as differences from something. So if your application is completely unique to you and idiosyncratic, then you'd put all your work into that no one else necessarily thought of or needed. Whereas if you wanted to put out something that was completely general and common, and that isn't particularly idiosyncratic to you, I know I'm being vague, but stay with me, then because it would be a shared concern, it should kind of already be there in the commons. Whereas in most systems, and particularly noticeably in the web, there's this mismatch where that gap is too big. So I end up spending a lot of effort working on features that seem like this is just what you normally have to do anyway. It's like in an ideal world, there would be no boilerplate. And I guess that's just another vague truism, like, in an ideal world, creating software would be easy and not hard. But I don't know, I've rambled a bit and I've lost sight of what you're originally trying to get out of me.
No, I totally empathize with everything you said. I just feel that we might get there in 1,000 years.
Yeah, unfortunately my thoughts on this are quite vague, and I don't really know what to say about it at the moment.
All of us, we're living in the Stone Age. We're sort of groping in the dark.
Particularly, there's a frustrating contradiction that I have, which is that in the least charitable possible way, I could just be complaining that I have to do work. Like, I have to, like, why do I have to implement this thing that should have already been there? However,
yeah, no, I can take it like that.
But in
I
many,
understand what you mean.
Yeah, in many contexts, there are things that are expected to already be there. That's what a standard core is. So there's just a bit of a mystery about how exactly communities decide this, and why it sometimes gets detached from what is actually the common case. If I'm correct in seeing that as the web being about web apps with certain requirements. Yeah.
I think we have time for one short question. Ollie, I see your hands up. Do you want to go ahead?
So there's been a lot of talk about the work necessary to get something done. But I think one other thing to be looking at is the work involved to reuse somebody else's code. Because I think, as Philip was alluding to, it's probably the case that many people on this call have done very similar work to what you've done, and there's probably somewhere, if you spend hours looking for it, some sort of library that's highly relevant, and that you'll find some libraries that hold too much, and some libraries that are just the right kind of size that you could pull in, and then you have to think about how you could pull that library into your code. And so there's all these costs involved with actually reusing other people's code and rereading it. And so there's a comparative thing going on, which is, yeah, this is a pain to actually do it myself, but it's actually probably even more of a pain to try and find somebody else who's done something that would really fit into what I'm doing. And so there's got to be a threshold point where suddenly actually the sum of work that is necessary goes way beyond the costs and the benefits and how well it's written up of using a library. So I think that cost of reuse is maybe needs to be added to your analysis.
Yes, cost of reuse. A notable thing about my work here was that I was reluctant to use any external libraries like jQuery or something. I was insistent on just seeing what is possible, or how it is possible, starting from the thing that everyone is guaranteed to have in the beginning, that doesn't require any additional learning, or at least from maybe it's just very relative to me. Maybe it's just because I already knew a lot of JavaScript and the basics of the web APIs, but not so much insert JavaScript library here. And so, but I also felt it was an important exercise to just, if I brought in a library that was capable of doing all the things I wanted, then I wouldn't learn much about the essential structure of the problem. And I also wanted to look at that and be able to talk about things like user interface physics and ontologies. But yes, I'm not morally opposed to using libraries and things in general. And if this was an attempt to do something else where I did I had relied on that, then I think yes, it's a cost that should be added in any discussion of the cost of software in general, certainly. Is this, I guess this is probably related to, just general integration of diverse mismatched components work, like what Stephen Kell's done with integration domains and things. Yeah.
Well, I think we're probably at time. Once again, I want to thank you, Joel, for your amazing paper and taking the time to answer these questions, and Clemens and Antranig for your generous critique of the paper. So, and thanks so much for everyone who attended.
If you close the meeting, will I not be able to read the messages anymore?
I'll leave the meeting open for a bit, and if you can share your paper or your slides or anything else you want to do, that would be amazing as well. And I imagine Jonathan can send an email out to the attendees with some links.
Yeah, that'd be because I'm not. Yeah, I don't know if it's hosted. Elsewhere. Yeah.
Can we save the chat log?
I don't know.
When you download it, it saves the chat log as well.
Oh, perfect. Okay, great.
Including private chat logs, I realized.
Oh. Wow. Well, we'll keep an eye out for that.
Oh, so only.
Okay.
Oh, where's the save chat button? Right side, save chat. Where is?
Well, I've discovered that hosts cannot raise their hands.
That's true.
Thanks, Joel. That was really great. I love this discussion. We talked a lot about. Well, there was a lot of questions and a lot of problems, not so many solutions and answers. And I think that's what makes it interesting.
All right, thank you.
All right. Thanks, everyone. Take care.
Thank you all.
See you all tomorrow, hopefully.
Yeah.